Good morning, dear students. Today we are going to do another practical, that is micrometry. What is micrometry? What is its application? It is a technique used to measure the size of a microscopic object. And this micrometry consists of a stage micrometer and an ocular micrometer. The stage micrometer looks exactly like a slide that we are commonly used in microscope. The only difference is that a scale is present. A scale is etched in its central portion. That is the only difference. Coming to the ocular, it is in the form of a circular disc having a scale in its central portion. Then what is the principle? Principle of micrometry is the calibration of ocular micrometer using the stage micrometer. That is the main principle. Based on that principle, using this micrometry, we are measuring the size of microscopic objects. Okay. This is the microscopic view of stage micrometer. So in this we can see so many equally spaced division, and it is not marked. So I am going to mark this one. This one is 0, and in between this line and this line you can see 5 divisions, and here also 5. So 5 plus 5, there is 10. Okay, similar again here 10. So next line 20, this is 30, then 40, 50, 60, 70, 80, 90, and last 100. So it is clear that the stage micrometer consists of equally spaced 100 division. Okay, and the stage micrometer is a standardized scale. That means we know what is the value of one division. I will show you closely. Value of this one division, it is known. What is the size? It is known. The size is one division is equal to 0.01 millimeter, which is equal to 10 micrometer. Okay, so in stage, one division is equal to 10 micrometer, and 100 such divisions are present in this stage. That means the length from 0 to 100 is 100 into 10, which is equal to 1000 micrometer. Is it clear? Okay, so stage, it is a standardized scale. It is etched in the stage micrometer, and its size is 1000 micrometer. And also size of one division is 10 micrometer. These 2 points we need to understand. Okay. Next I am going to show you how to fix ocular micrometer in the microscope. In the previous slide, I already showed you what is the appearance of the ocular. It is in the form of a circular disc. So next I am going to show how we need to fix the ocular micrometer to a compound microscope. Okay, this is the eyepiece. I am going to open it. After opening, we can carefully keep this ocular micrometer inside this eyepiece very carefully, and after that we can replace the lid and can tighten. In this way we need to insert the ocular inside the eyepiece. After fixing that ocular micrometer inside the eyepiece, we can see that in this form. And this also is a scale having marking from 0 to 100. But in this focus area, we can see only from markings from 20 up to 90. Anyway, here also, this scale also have 100 equal division. But the ocular micrometer doesn't have any absolute value for each division. So that is why we need to calibrate the ocular micrometer against the stage micrometer while using each type of objective. So that we are going to do next. That is calibrating this ocular against stage under 10x objective. That's what I am going to show you next. For that, we need to keep both the ocular and the stage. We place it in the stage of compound microscope, and ocular we kept inside the eyepiece. So both scales we can see now for the purpose of calibration. Okay, calibration means we need to find the coinciding line, nearby coinciding line. So that's what we require here. Uh, so here in this adjustment, we can see that this line means this turn marking and this line is coinciding, and similarly show you in zoom way, this line is coinciding with this line. Okay, so in ocular, how many divisions are there between the coinciding line? That is the next thing we need to note out. So either we can count up to here, this is 5 and plus 1, 6. 6 divisions are there between the coinciding line. For easy, in another way we can find it out. Just only need to look what is the highest value of the two coinciding line. This is 16. So we can write 16, and the least value, this is 10. 16 minus 10 is equal to 6. That way also we will get how many divisions are there between the nearby coinciding line. Okay, so in ocular it is 6. Ocular micrometer. Similar way, we need to find how many lines are there between the coinciding line of stage. We know that up to here it is 5 divisions, and then as a continuation up to here again 5 divisions. So total 10 divisions are there. 10 divisions are there in stage. Okay. Then I am going to show you how we are calibrating it. Okay. For calibrating, we know that in the stage 10 divisions are there between the coinciding line. So that will form 10 division. 10 into, we know the value of one division. It is 10 micrometer. Right. So 10 into 10 is 100 micrometer. Okay. 10 into 10, 100. So, In the ocular, if we consider the ocular, that 6 division between the coinciding line, its length is equal to 100 micrometer. Clear? So that's what I am going to write next. Uh, Here 6 ocular division is equal to 100 micrometer. Correct. And what is the value of 1 ocular division? That is an unknown micrometer. Okay, then we are again going to derive it in a mathematical way to find out this unknown value. Okay, for that we need to cross multiply this one. We need to cross multiply. In this way, I am going to cross multiply. That in what way we can write 1 ocular division into 100 micrometer, which is equal to 6 ocular, I am writing in short form, otherwise there is no space, ocular division into unknown micrometer. Okay. For further simplifying this equation, I am going to divide each side of this equal by 6 ocular division. So here 6 ocular division, and here also I am going to divide the whole by 6 ocular division. Okay, then we can cancel this 6 ocular division and this 6 ocular division. We can cancel. Here this ocular division and this ocular division we can cancel. What left after that? It is 100 micrometer divided by 6, which is equal to, that value is the unknown micrometer. What will be this value? 100 divided by 6. It is 16.6 micrometer. This is the calibration factor for ocular under the objective 10x. Okay. This is the way how we reach this equation. So while you are doing performing this practical, it's not necessary to work out all these steps. Directly you can go to this step. For understanding how this equation you got, how this step you got, that's why I explain all these steps. Clear? Next, we need to find the width of a specimen under the 10x, because we already finished the calibration. That's what next I am going to show you. We are going to measure the width of a specimen under 10x. For that, we need to remove the stage micrometer from the stage of the compound microscope, and by keeping ocular inside the eyepiece in a different slide, in another slide, here we took a hair. We placed that hair in that slide and kept under the microscope. Under the microscope, we can see that hair's width in this way. So here what we need to do is just to count how many division is covered by this hair. For that also it was easy when if we notice the highest value. Value here it is 40. Highest value here it is 40. So 40 minus, and the lowest value is 35. 35, which is equal to 5. So this hair cover 5 division. Okay. So the width of this hair under the 10x objective is 5 into the calibration factor of ocular for 10x, that is 60.6, which is equal to 83. Okay, 83 micrometer. 83 micrometer is the width of the hair under 10x. Okay, I think it's clear. Okay, next we are moving to calibrate ocular against stage under the 40x objective. Okay, calibration of ocular under 40x objective. In the similar way as we arranged for calibrating under 10x, here also we place stage in the stage of compound microscope, and we kept that ocular inside the eyepiece. Next we are going to calibrate it. For that, first we need to find the immediate or nearby coinciding line. We can see here that this line and this one are coinciding. In the scale, wherever you can locate the nearby coinciding line, that doesn't matter. Wherever you locate, whatever it be, the number of division will always be same. Okay. Anyway, in this adjustment, I locate this line as the first coinciding and this one as the second. Then next we need to count how many divisions are there. For counting, the easy way, first we need to notice what is the highest value here towards the right side. It is 34. Okay, 34. 34 minus least value here. It is 10, 9, 8. 34 minus 8. 34 minus 8, that forms 26. 26 divisions are present in between these two coinciding lines in ocular. In the similar way, we need to find how many divisions are present between the coinciding line in stage. Up to here 5, then again here 5. 5 plus 5, 10. Okay, so in stage 10 divisions are there. 10 in stage. Okay, we know that one division in stage is 10 micrometer. So 10 into 10 is equal to 100. And in the previous calibration process, I explained you what is the method of derivation. So here I am not going to explain that again. Simply I am going to write the equation in this way. 10 into 10 is equal to 100 micrometer. That is the length size of this area of stage against the corresponding ocular. So that is 100. 100 divided by number of divisions that is present between the coinciding line in ocular, that is 26, which forms 100 divided by 26 is 3.84, right? 3.84. This is the calibration factor for the ocular against stage for the objective 40x. Clear? Next, we are going to measure the width of the specimen after removing the stage while keeping the ocular in the eyepiece. That's what I am going to show you next. Measuring the width of specimen. For that, as I explained to you before, take a hair, means that the same hair that we used under the 10x, that itself we need to place in a clean slide and to view it by keeping it under the 40x objective. Then we can see that in this 4. Here also we need to count the divisions covered by that hair. So, in the same way as I already explained to you, first we need to notice the highest value here. It is, I think, this is 50, 50, 51, 52, 53, 53, 53. Okay, 53. And this is 31. 53 minus 31. 53 minus 31, which is equal to 22. Okay, that is the number of divisions. Okay, next we need to multiply that division with the calibration factor that we calculated for the ocular under this 40x objective. It is 3.84, which is equal to 84.48 micrometer. Under 10x, what is the measurement we got? That is 83 micrometer. Almost same. So that is the calculation. In this way, we are calculating the width of or the length of the specimen using the micrometry. Okay, it's clear. With this, we finish today's practical. Thank you.
I'm an icon, man. I'm a girl about a 10. I should fuck her in a Benz.